So this brings us to the main event. In today's session, we are joined by David Okeod, a cloud security consultant and MVP. He will be showing you some practical techniques in Azure Container Security. The session will run for approximately 60 minutes with time for questions. At this time, I will pass the mic over to David. David, whenever you're ready, you can override my screen.
Thanks very much for that. I really appreciate you for that introduction, Rebecca. Thanks very much for that.
Just to confirm, welcome.
Yeah, can you see my screen?
Yep, I can see your screen. It's perfect.
And also, is my video coming up? Video all good?
Yep, we have you loud and clear.
Awesome. Thanks very much, everyone. So thanks very much, everyone, also for joining this call. So just quick introduction of myself before we proceed with the agenda for today. So my name is David Okeode. So I am a cloud security consultant. And what that means is I help organizations to secure their cloud environment. So whether that's their expert level assessment and training of the different personnel in the organization on how cloud security principles work. So that's like my main focus area. So I've been in the industry for over a decade now to the different security check templates and different security check tooling that I've been part of authoring and also contributing to certain open source projects, most notably Lava. So for those that are familiar with Paku, which is an AWS exploitation framework that's out there. So there's an equivalent of that called Lava, and that's an amazing tool that I do contribute to. So please do check that out if you're yet to check it out. Okay, so in terms of the agenda that I'll look to go over today, I'm going to start first with, so apologies there. So I can see that my animation is a bit messed up. So there we go. So let's go sort out the animation. It's got number 2 for number 1. The joys of so here we go. So we start first with cloud native. What is cloud native? We'll try to understand and have a common language for what we're describing or talking about today. Then we're going to talk about just an introduction to Azure Container Services, talk about some of the security challenges involved in securing containers and especially implementing that in a cloud native way. Talk about some principles or some strategies when it comes to effective container security, and then I'll have a demo at the end. So for those of you that have attended some of my presentations in the past, you know I like to deep dive into things from a technical perspective. I will still deep dive into things a little bit from a technical perspective. However, I will try to give as much of a big picture as possible rather than delving really deep in this particular session together. So that's sort of like the approach that we'll take. So much more big picture. Let's understand strategies. Let's understand principles approach versus a deep dive technical approach. So the first thing is around cloud native. So if you stop what you're doing now and you ask about 10 different engineers that you know, then 10 different architects, 10 different developers, and you say to them, can you define cloud native for me? What exactly is cloud native? And there's a good chance that you're going to get different answers from all 10 of them, depending on the book that they're quoting, depending on the perspective that they're coming from. Cloud native is defined in a variety of ways. However, to sort of bring sort of like some commonality in our language today, CNCF, which is the Cloud Native Computing Foundation, has this definition of cloud native. So said cloud native technologies empowers organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid cloud. What does that mean? So what they're talking about is that any technology that empowers us to build and run applications that can respond to rapid changes. So that's talking about applications running that in that environment, that allows us to be highly scalable, right? Being able to accommodate the demands and the requests that coming into the application, and allows us to be resilient. Any technology that powers that can be considered to be cloud native. So really, what we're talking about, it really doesn't have much to do with just public cloud, the way many people think about public cloud. cloud native can be in any environment as shown on the screen. It can be in a private environment, it can be in a hybrid cloud environment, and of course, it can be public cloud environment. It's just talking about certain principles. So the definition from CNCF went on to mention that so technologies and the services like containers, microservices, service mesh, immutable infrastructure, declarative APIs, all these different technologies can be considered to be cloud native, right? Because what they do is they empower us to build and run applications that can respond to rapid changes and can scale intrinsically. If you're interested in finding out more about the sort of like the official definition and description of what cloud native is, I'll refer you to the URL that you have on your screen and that you can refer to see what the definition is over there. So let's move on a bit further here. So now let's go have a quick look at Azure Container Services. Let's give a quick overview of Azure Container Services because we're here to talk about Azure Container Security, effective Azure Container Security. Let's talk about this. Now, from the previous slide, one of the things that we saw there is that container services are some of the technology that powers cloud native implementations in the modern world, right? So, and that means that container services that run in Azure help us to build and run things in a much more cloud native way because that technology powers that. So when we talk about containerization in general, we are mainly talking about three main aspects of things. We're talking about building container image or what is referred to as the build time, right? We're talking about storing and distributing container images, which are containerized application in what is referred to as the ship time. And we're talking about running our containerized applications in a variety of environments, and that's referred to as the runtime. So we have these three different aspects that we usually approach things when we look at things. So starting at the build time, in Azure, we can have a Docker host. A Docker host is simply a virtual machine in Azure that has Docker installed. And we can install Docker or a container runtime engine on a virtual machine in Azure. And then we can use that to build our applications. Again, that's part of like the build time. And when you look at this option of using a Docker host, spinning up a virtual machine and using it to build your container images, this option may not be considered to be the most efficient because you're having to look after operating system and all of that stuff. However, I have seen many organizations use this approach, right? And also you may be surprised if you look within your Azure environment and you look closely. You may be surprised what you find that people are doing and developers are doing in your environment. So just be aware of that. So of course, Azure Pipelines can be used. Azure Pipelines is an automation service that's in Azure DevOps that allows us to automate the build, the test, and the deployment of applications of any type, including containerized applications. So we can use that to build our container images and to automate doing that. There's also a service in Azure called Azure Container Registry Tasks, which from what I've seen in my own experience, it's less talked about for some reason. So this service can also be used to build container images. Actually, one of the popular use cases that I use this for is I'm doing a demonstration. If I do not have Docker installed locally on the system that I'm using, I could simply take a Docker file, take the different application and the dependencies of the and the files that define the dependencies of the application, send that over to Azure Container Registry Task. It's going to use the Docker file and it's going to build my container image for me in the cloud. So the main use case of this service, however, it's mainly for updating base images of container images. So if I want to update the base image of my container images, I do not want to have to run my image through a pipeline again, just because I want to upgrade it, just because I want to update the base image. If there's a new base image that exists, I have a task that's set up that automatically updates that so I can update things at rest rather than having to run it through a pipeline again. Of course, when we talk about ship time in Azure, there's one main service that we're talking about, which is Azure Container Registry. So by the way, specifically focusing on Azure here, Microsoft does have other services that fit into sort of like this category. For example, for Azure pipelines, there's also GitHub Actions that you can use to automate the build of your container images. When it comes to the ship time, there's also a GitHub Container Registry that you can use to sort of like store and ship your container images. But we're focusing on Azure in this case. So Azure Container Registry is the service that powers that in Azure. So it's based on Open Docker Registry version 2.0. That's the same application that's running Docker Hub for those that are familiar with Docker Hub. So Azure Container Registry is based on that, and we can use that to store container images that we want to ship, and we can use that to distribute that. So when it comes to runtime, it's a bit more complicated in Azure because there are a variety of services in Azure. But you can sort of classify those container runtime services in Azure into two categories. So services that support orchestration and services that do not support orchestration. So those are the two main categories of containerization services in Azure. Container runtime services in Azure. So when it comes to the services that we can use to run containers that do not support orchestration, so we have virtual machines. So again, you may be thinking that's not like the most efficient way to run containers. I know, however, I've been involved in multiple audits for many organizations, from startups to major enterprises, and you'll be surprised where people are running production applications. You'll be surprised when you do an audit. So just make sure you have a quick look at your environment. Make sure that things are not done in a way that you don't expect. So people can run container applications on virtual machines in Azure. You can use a service called container instances. Container instances are just managed Docker hosts. In other words, I don't want to manage the operating system. I don't want to manage the container engine. I want those sort of responsibilities to be offloaded to Microsoft, and I want you to run that for me. Now, just looking at that from a security perspective, you can begin to see that when we talk about container security, it cannot be a single approach, right? It cannot be a single approach because you're talking about things from multiple perspectives. You're talking about things when you're building them, when you're shipping them, and when you're running them. And the environment that you're running your container applications vary, the behaviors vary, the access and the responsibilities that you have does vary in those environments. So for example, container instances, it's not a service that you typically manage. However, if let's say there were to be like a vulnerability on one of your container applications that you're hosting, an attacker could actually leverage that to land directly on the OS. And when they land on the OS, guess what? They have root privileges on that, and they can see any other container that's running within that container group. So there's a lot of things to begin to consider, but then it has to be a conversation about which services are you using to run container images. So that'll probably be my first question for you today. If you're here to find out how do I implement effective container security in my environment, which of the services are you using in your environment? That's where you start from. Understand which services that you're using, understand the different scenarios that come into play depending on the services. We'll cover some of those in a few minutes. We have the Azure App Service. Azure App Service is a service for hosting web applications, API applications, and mobile backend in Azure. However, you can also use this to host your web application, mobile applications, and mobile backend applications, API application as container images. So it always gives you the option. Same as Azure Functions. So Azure Functions allows us to be able to host our applications as code or as container. So that follows sort of like a microservice approach in terms of Azure Function. And if you're familiar with like services like Azure App Service and Azure Functions, you know that the underlying hosts are transient hosts, right? Because the host can be transient in terms of they can scale up intrinsically and then they can scale down as the load goes away. So there are other considerations that you begin to have when you're running containers in services like this ones. There is a service in Azure called Azure Batch, which can be used for high performance compute scenarios. So high performance compute scenarios, that's when you have a bunch of tasks that you want to execute. You want to schedule that to run in parallel across a cluster of CPUs. Azure Batch is the service that you can use to do that. So Azure Batch allows us to be able to define our task to run in a container image versus just natively on a virtual machine in Azure. So these are services that we can use without orchestration capabilities that we can use to run container applications in Azure. With orchestration, we have three main services. We have the Azure Kubernetes Service, which is managed Kubernetes platform hosted in Azure. We have the Azure Service Fabric, which is a microservice service mesh approach provided by Microsoft. So mainly targeted towards like the more Microsoft development shop. And we have Azure RedHat OpenShift, which is a managed service that we're hosting in Azure. So again, I want to really emphasize, look at this picture. When we talk about container security, because many times I talk to people, say, hey, what's going on with container security? One of the stuff that you hear back is people just go, yeah, we're scanning our images. You go, yeah, we're scanning our images. Okay, what other services are you using when you're running them? Have you considered the security implications of running your container in Azure function, security implications that you need to consider there, or whether you're running in Azure Hub service? Oh, I'm not aware of that, and stuff like that. So you have to have this clear understanding and make sure you have an holistic view. When we're talking about containers, being a technology that powers cloud native that we defined in the first slide in terms of what cloud native is, we're talking about we have our code, and our code is running in a container environment. Container environment can be powered by different runtime engines. So that could be Docker, that could be Containerd. So recently, Azure Kubernetes Service moved away from Docker and moved towards using Containerd as the runtime environment for running container applications. And we have containers running on a node. So if you're running on something like Azure Container Instance, you can select whether the node is going to be Windows or Linux. It's the same thing if you're running your containerized web applications on Azure Hub Service. You have the choice. Actually, you know what? Before I move any further, let me just go over to my environment very quickly to show you some of what I'm talking about. So if I head over here, let's go to create a resource. I won't actually create a resource. I just want to show you what I mean by that. If I go to select that and I say I want to run my web application, I want to run it as a Docker container, I can select whether the underlying operating system will be Linux or Windows, which again, you have different consideration. And it's going to be the same thing if you're using Azure Container Instance. You can specify sort of like the context that that's running on. So you can define that in terms of the node. And if you move further, the node can just be hosted natively on the cloud platform, or the node can be managed by either an orchestrator or a service. In the case of Azure Kubernetes Service, you have Azure Kubernetes Service managing your Windows pool cluster pools, or what are called node pools in AKS, or your Linux node pools. If you're running on Azure Hub Service, it's going to be managing an underlying Linux node or Windows node. Same with, so Azure Function only supports Linux containers at the moment, so that's on the Linux. Azure Container Instance can also be Linux or Windows. So it can be any one of both. So same as some of the others. So now you have like these different frameworks. And then of course, the orchestrator or the service is managed by the cloud, or the nodes directly is managed by the cloud. So if you have a look at this, you can see again, more reasons why this is a bit complex in terms of what we're talking about, because issues, risks, vulnerabilities can be introduced at any of this level. Right? You may be all good. You're doing your container security, your vulnerability checks and all of that stuff. However, simple misconfiguration on the cloud platform, if you're running things in Azure, will lead you to a big issue. If you're not familiar with what I'm talking about, I'll recommend go to my YouTube channel. So search for my name on YouTube channel, David Okeode, and just search for David Okeode Containers. I've done at least maybe about 2 or 3 previous presentations at Microsoft Reactor where I demonstrated, there was one scenario where I demonstrated how an attacker could exploit vulnerabilities on the cloud to do damage on container services in the environment. There was another scenario where I explored Azure Container Instances and how running containers in a serverless environment like Azure Container Instances can be exploited by an attacker. So I won't go into all those scenarios again because I've previously talked about them in previous Reactor events. However, you can check out those videos and make sure that you get the information that I'm sharing there. So in terms of the major security challenges of running cloud native technologies like containerization, So I like this diagram from Pete Cheslock. So because DevOps workflow are heavily automated, right? For many organizations, security checks are still often manual, right? So DevOps and security team, for the most part, for many organizations, they are still measured differently. So some are measured for innovation, while the others are measured for risk management. Changes that impact on security posture happens continuously. Let me just quickly highlight this too, because we're talking about container security. If you have a look at this screenshot from a document that Microsoft has on sort of like describing organizations that are adopting container framework in terms of how they build, test, and deploy their applications. If you have a look at this, so you see a company like Netflix, they have over 600 services in production powered by container services deployed. They deploy 100 times per day. Uber, over 1,000 services in production, deploying several thousand times a week. Your organization may not be doing as often in terms of deployment. However, you are doing more deployment than the security teams are used to, right? So they're not used to this level of velocity, this level of speed and pace. Those brings challenges that we have. Like the example of the security person over here, just really, really looking sad because he's trying to clean up all the mess that's constantly being created. So because all the truth is that of all the several thousands of deployment that Uber are doing in a week, there are certain changes that they are making that's impacting on security posture. How do the security team keep up with that? How do they keep up with that? That's a challenge for many. Also, when we talk about accelerating delivery, that in some cases also means we're accelerating risk delivery. If there were to be like a particular security mistake that was made and not something that we have the proper automated test for security checks in place to catch those sort of mistakes before we sort of deploy those, what we'll end up in a situation where our actual process that's driving innovation is also driving the propagation of risks in our environment, right? And also depending on how you've implemented your security structure, right? So for example, security teams, I've seen situations where security team goes in to the different dev team and they go, okay, dev team, here is your pipeline for how you build your container images. You're going to have this security check that's going to check for image vulnerability. You're going to have the security check that will check for compliance. However, after security team left, guess what? The dev team were doing deployment, was failing. They tried to troubleshoot, they could not figure out. Guess what they would do? Right click, disable, right? Let's move on and get things going, get things moving. So how you implement things also plays in this particular case, right? People can just skip checks and just go skip it, let's move on, because what we care about is how we need to deliver this innovation. And all these challenges that I've mentioned earlier, they essentially have led to what I call the status quo of container security. What that means is that for many organizations that I see, here is what they consider to be security for their containers. And you need to ask yourself that question. Is this what you are considering to be security for containers in your own environment? Because when I go to organizations, some of the things that they do is, oh yeah, we are following some security best practices. Right? Following some security best practices. We just go to Microsoft website, we find about one or two of them that are easy for us to implement. We implement them. That's all good. And we have some image vulnerability scan. We're checking for some vulnerabilities. Which environment are you checking that? Are you checking that at build time, at runtime? Oh no, before we build that application, we always check before we build it whether there's vulnerability. Okay, but vulnerability changes. New vulnerabilities are added all the time. What about the one that's running in runtime? Right? Are you assessing vulnerability for those also? So, but that's what many organizations call container security. When they say container security, that's what they mean. And what they mean is, oh, we've got a firewall at the ingress and ingress point. And this is, unfortunately, the status quo of container security for many organizations that I see today. When they say container security, they're referring to this. As the picture shows on the left-hand side, that's heading for doom. Just reminded me of a Nigerian comedian. Mr. Macaroni that has like this old character about Professor Doom. So anyway, so where you go, yeah, you know what? We're doing a few things that we can do. And, I'm doing my own container security image vulnerability check. That's it. And we're all done. So, and that's the whole point of this particular session, which is container security to be truly effective. That's what we call the session, needs to be from build time all the way through ship time and all the way through runtime. It needs to cover every aspect of that for it to be truly effective with the pace and the velocity that we are talking about. Let's move further a bit. One of the things that makes that understandable for many organizations, for every 10 developers that they have one operations person. And for every 100 developers, they have 10 operations people, and then they have one security person. So you can see the reason why the security person was looking very sad. And what this leads to is, so this is a report from Google's. So Google releases what they call state of DevOps reports. And one of the things that they asked customers was to say, how are you adopting in terms of cloud native technologies like containerization? And how are you adopting in terms of your different maturity principles? What they found was that people are doing a great job of automating their build. Sorry, let's clean that up. People are doing a great job of automating their build. They are doing a great job of automating their tests and their unit tests, their application tests. However, when it comes to things like automated security tests, people are doing a really bad job of that, right? So just about 15%, that means out of every 100 organizations, just about 15% of them have anything that has to do with containerization security assessment when they are automating the build, automated security checks in terms of their pipelines. So let me just quickly talk about some other key points, and then I'll do some demo. So let's look at the time. Okay. So some other very, very quick points to highlight to you. So what you want is that when we talk about effective container security, we mentioned it needs to be all the way from the design phase, all the way to the build, all the way to the test, to deploy, to operate, to secure. I'm not sure if someone has a question. Someone's mic is unmuted. So if we can please check our mics, that'll be great. Thank you. So if I have a quick look at this, so it has to be from the design phase to the build, test, deploy, and operate. So here's some quick practices and principles when it comes to effective container security for your Azure environment. So leveraging the capabilities of the security platform and integrate with it. We'll talk about this a bit further in another later slide. So there's the whole concept of shift left. Yes, you do need to shift left when you're using containers. The rate and the pace at which people are deploying things, the only way that security is going to work is that security capabilities has to be democratized and moved to the left, moved closer to the development team, moved closer to the team that are actually building the applications and building the containers. So, but what you also see is that some organizations, all they're doing is they're just shifting tooling. All they're doing is just saying, here's a tool, as an extra tool that you can use. People are already bugged up. They already have a lot of things to do. They probably don't care about your tools. So what you want to do is to move that to shifting expertise versus just shifting tools. So what you also want to do is at this particular design phase of your application lifecycle, you want to ensure that you have the policies that you're going to be assessing against defined as code. So security policy as code is a very important thing. So I've seen organizations take different approach to this. So some organizations, what they'll do is that they will essentially empower the different teams to write their own security checks. So if I'm building an application and I'm going to be writing the policies that the application is going to be assessed again in production. You said, David, that's a bit weird, stuff like that. So the whole idea behind that is the development team knows their application. So if I'm building a container image, I'm writing my Docker file. Within my Docker file, I'm specifying the ports that I'm exposing within my image. So I'm specifying that in my Docker file. I'm specifying the processes that it's going to spin up when you run the container image. So I understand the application. Why can't I use that to define a policy to say, whenever this application gets to production, it should only be exposing these ports that I've defined when I was building it, and it should also only be spinning up processes that I've defined when I'm building it. So it's only going to be spinning up that particular process. And then you define that and you implement that as code, and that's going to be enforced at runtime, so that if that begins to deviate and all of a sudden the application begins to listen on a part that it wasn't designed by the development team to listen on, then that gets alerted and that gets into, you can take actions on that. However, what's really important here is you have to define the ownership. So this needs to be really agreed with your teams. Who is actually going to be responsible for writing these policies that's going to be enforced at runtime? So you're defining those at the very beginning at the design phase. Who is going to be responsible for approving the policies? Maybe the development teams write their own policies, security team approves that, and once it's approved, then that can be used. So who gets alerted if there were to be any deviations from what's defined? Right, who's going to own the remediation? So you have to clearly define those for things to work and to be effective. Otherwise, you get into a process issue in your organization. At build time, you want to leverage detection of different types of issues that could happen. So you want to ensure that you're checking your code. So that's using source composition analysis tool sets. You're checking the binaries that's used, the images that you're using, the base images that you're putting, and the images that you're using. And when you say you're checking them, this is another thing that I see people don't clearly define. Like I showed earlier, some people go, yeah, we are doing container scanning. What are you scanning for? Right? In many cases, what I find people are doing is they're scanning for vulnerability, and that's about it. But there are multiple risks to running containers more than vulnerabilities. In some cases, what they talk about is they're talking about vulnerabilities, and they're talking about compliance checks. So, which is good, which is better than if just checking vulnerabilities alone, which is better than not checking anything. So checking for vulnerabilities, they're checking for compliance. However, there are different threat factors that also exist. So I'm not sure if anyone has seen this, but Unit 42, first known Windows malware that's running on container. So if you've not yet seen that, I highly recommend you go to have a look at this document. So they have a document that goes into that in more details. So I don't have that, unfortunately, in my environment open. However, so go check out this document, right? Go read about it. So again, the threat vector changes all the time. This is a highly evolving environment. So this is the first known one that was really discovered. So you see how it's sort of like exploiting the Kubernetes API to compromise the entire cluster and to essentially compromise all the nodes on the cluster to now move laterally within the environment. So be aware of that, and there are multiple different malwares that are targeting Linux containers also. There's another one called is a Gruboid, which is a Linux malware that essentially just attacks different Docker nodes in the environment. So be aware of that. So you're not just checking only for vulnerabilities, you're checking your binaries for malware, you're checking for compliance issues and configuration issues. So make sure that you're holistic in terms of your approach. And again, the only way that this can work is you have to do that as early as possible. So you have that as part of your IDE check. So here's an example of that. So as people are writing sort of like their templates, their Docker file, you're getting instant feedback to let you know, okay, you're messing things up with the configuration that you have over there from a security perspective. But also, pre-commit in the repository, and also in the repository, you're checking that, and also in your pipelines, which we're talking about, that you're also checking that. So, and one of the whole idea behind that is that the longer it takes for you to identify this issue, remember, we're not just talking about vulnerability. We're talking about vulnerability, but we're also talking about compliance issue. We're also talking about malware issues that you're checking for. And we're also talking about configuration, other configuration issues that you're checking for. The earlier you can identify those, maybe right from when things are being developed or when you're building things, the better it is, because as you go further, the impact of the defect gets larger. So the whole idea behind that is that for maybe one issue that you fail to detect over here, when it comes back from the security teams, that's going to turn into about 100 alerts. that you now have to go try to resolve in terms of your 100 alerts. Of course, you can always do that by rolling out a new version of your image, and then that's going to sort out some of the issues. But what that means is that you have a bunch of unplanned work that you did not plan about, that now it's going to sap away from your productivity, where you could have been more effective by making sure that that's part of your assessments to begin with. Okay, in the test phase, again, you're testing, you're checking for the same thing that we talked about, checking for security issues, checking for vulnerability, checking for malware issues. And this is very important. You need to consider that in your environment. You need to look at whatever pipeline tool sets that you're using. Is there a way for you to implement the sort of checks that you need to implement in such a way that security checks cannot be disabled? The stories that I have to tell about that, that's for another day. So are people allowed to sort of disable security checks if it does not fail to get things going? Check those, make sure you're addressing those. I want to move very quickly here because of time. And again, deployment phase. So I mentioned this earlier, new vulnerabilities occur all the time. So you're saying, yeah, I've done my security vulnerability check over here before I deployed it. Okay, but then there's been 100 new vulnerabilities that has been detected since you did the deployment. So what are you doing about those? Are you even identifying those at all? Do you even know if they exist at all? So you'll be surprised, for many people, they do not know. When they say we have container security, all they're saying is, I'm doing a little bit of check over here, and that's it. They have no idea if there's new stuff that has been introduced over here that they do not know about, right? So, make sure that you're checking things at the point of deployment. So that could be, even though you've already scanned your images before you get them into the registry, before you pull that image from the registry and deploy it into a runtime environment, you do another check. And you say, okay, let's do a much more updated check at this phase. And if only if it goes through that check, we will go ahead and deploy that. So multiple ways to really implement some of these principles that I'm putting over here. But again, there's not enough time for us to dive into everything. In terms of the operation, so when you actually have your containerized application running in a production environment, you want to also monitor their behaviors. Why? There are some of these things that some of you may have heard about called 0 days, right? So 0 days do exist, right? Like the case of the one that happened recently with a popular monitoring software company. The package passed through vulnerability checks, no problems. Why? Because it's 0 day. No one knew about it. It passed through compliance check, no problems at all. However, organizations that were able to address those sort of 0 day issues were organizations that were looking at behaviors of teams at runtime. And for some reason, for whatever reason, organizations seem to forget this particular aspect when they talk about container security. For some reason, because I've been in the industry for about 10 years now, so I've seen things evolve like over time. Probably not as much as some of you on this call. However, I have seen things evolve over time. For some reason, people think that, because it's cloud native that we defined in the beginning slide. So whether it's because it's cloud native, all of a sudden, all the different security principles that we've known don't apply anymore. All those different security principles of looking at behavior at runtime and looking at the processes and looking at the network connections that something is making at runtime and looking at the file system interaction that it's having, all of a sudden that's out the window because it's cloud native, right? That's not the case, ladies and gentlemen. That is not the case. You absolutely need runtime, because if you do not have that, all that's needed is 1 0 day that passes through all your checks, gets to your environment you didn't know about, but because you didn't have any runtime, that's going to get through and you're going to be one of the statistics. So it's important to have that. So monitoring behavior in terms of you're having like maybe a much more stricter allow list to say these are the different processes that are allowed to be spun up in this environment. Anything else is not allowed to be spun up, and having all these types of check at runtime. So that's very important. So there are many other things that I can talk about in terms of secure, but what I'm going to do is I'm just going to quickly go show you a quick demo. So the demo that I'm going to be showing you, which I have a few minutes, and I'll just try to be as quick as possible with this, is I have an environment that I've prepared. It's got certain Azure Container it's got certain Azure Container Services with Container Registry, AKS, Container Instance. It's got Azure App Services, Azure Functions. I'm going to be using pipelines to show you sort of like the shift left capabilities and tests and checks that you can put in place. And there are other things that can be used to enhance security. So things like putting your secret in Key Vault, your flags in the Azure Config Store, and other things. So, however, I'm just going to go ahead and quickly talk about some other aspects of this. So for the demonstration, I'm going to be using Prisma, and I'm going to be using Bridge Crew by Prisma Clouds to do the demonstration. So let's go over here to this environment. So the first aspect of this that I'm going to show you is sort of like some checks that I'm sort of putting here at the build and test phases of a sample pipeline that I'm using. So in this particular case, so for the build and test, before I even build the container image, I do a quick check of the code repository where the code that's going to be containerized is coming from. So the main idea behind that is it's not the most efficient way. We're talking about efficiency. It's not the most efficient thing for me to say the dependencies that exist in code actually have a bunch of vulnerabilities, have a bunch of issues with them. However, I'm going to build my image anyway. Then I'm going to get further down to when I'm about to deploy, and then it's going to fail. And then I'm going to send back 3 alerts to the dev team, and I'm going to say, this failed further down here. And what that's going to do is loss of productivity. They have to do context switching. So typically when developers finish building something, what do? They move on to something else. Now you've sent something back to them. They've got to go, what was I doing with that thing over there? And then they have to go, oh, okay, we're on this stage. Let's go back to go trace what we were doing over there again. So that's not the most effective in terms of that. So I want to make sure that before I even start building, let's check the dependencies that exist over there. Let's check the Docker file, and let's check for configuration issues. So being holistic in terms of the things I talked about, vulnerability, configuration issues, malware, compliance issues. So scan-based images, and also, again, just detecting all those 4 aspects of vulnerability, compliance issues, and all that stuff. So checking those. So deployment, maybe I'm going to be deploying the services that I'm going to be using, like my Azure Container Instance that's going to be hosting my application on my Azure App Service. I want to ensure that I'm doing a quick analysis of those. So whether I'm using Azure Ham template or using Terraform, I want to ensure that the configuration of my Azure Kubernetes Service is all good. So this is where you can sort of automate the checks for your security services. So this can be called you can call this security policy validation as code, whatever you want to call it. So that's fine. So, but I won't go through that because, again, many of you already know this. You can just search for AKS security best practices, and you find a long list of documents from Microsoft, and just knock yourself out in terms of, here you go. You've got this for the cluster operator best practices, and then you've got this for this one. So what you want to do is that with all this long list of best practices and all that, you want to codify this. You want to codify them so that you can codify the assessment. These are not things to digest manually. These are things to codify in your environment, and you're checking as I'm deploying my AKS clusters, I'm updating their configuration. Are they aligned with those best practices? And if not, I can quickly catch them. That's the only way you're going to be able to handle 1,000 deployments a day. So registry image can check. So again, remember, vulnerabilities change over time before things get deployed. I'm actually going to check the registry, check that it's all good. In cases when I'm deploying applications into a serverless runtime environment, so something like Azure Container Instance or Azure App Service, or Azure Functions. So those are serverless container instance because I do not have access on the underlying server that's running these containers. So however, what I can do is I can embed like a runtime defender in some cases. So some tools exist to embed runtime. And so essentially, if I'm running it, if my container is going to be running in a service like Kubernetes Service, I don't need to embed like any runtime protection. However, if it's going to be running a serverless service, I can automate the embedding of runtime protection, where I also do policy as code to go define the policies that need to be adhered to before that gets before that gets run in production. So those are the kind of checks that I'll put in place. So, and one other thing that I wanted to show you was sort of like the operation and secure, which is I'm applying my web application and API security policies. as code, and I'm applying runtime policies as code. And again, I'm going to be showing you that using Prisma Cloud and Bridge Crew, and then leveraging these Azure services like Kubernetes Service, container instances, and all the others. So let's go have a quick look at that. So the first one aspect I'm going to show you is this aspect of scanning container images. Those are the different issues that I'm detecting. I'll move very quickly because of time. Scanning base images and detecting all these issues that I talked about. So let's go over to my Visual Studio Code, where I'm going to show you some part of that. So at the moment, the way that I've sort of set this up, without going through everything in details, is I've set this up sort of like in different stages. So I have sort of like a pre-build stage, which is sort of like the build and test stage. So in this case, pulling the connection information from Azure Key Vault, which I've temporarily disabled for now because of time. So installing the tools that I'm going to be using for the different checks that I'm going to be doing, scanning the repo for different issues before we actually get to building, so that we quickly fill the issue, goes back straight to development team before things proceed. So doing that in terms of my Docker file, checking the configuration in them and all that stuff. So that's what I'm going to be starting with. And also to help sort of like what I'm doing, I have certain flags. So typically what I do is I have these flags in a service in Azure called Azure Config Store. If I go over here, however, because of time also, I won't be able to go through all of that. So, but what I typically do is in this particular case, I'm using Azure, I'm using this to sort of control sort of like the flag. So that is one way for you to sort of take away the ability for people to disable those policies without consulting a centralized team, like maybe the security team. So because that's all controlled using a flag, and the status of the flags are controlled centrally over here. So whether I set this to true, or whether I set this to false, whether I enable that, or whether I want to disable that and all that stuff. But for this case, I'm just going to move on and stuff. So I'm just going to set everything to true, so it's going to fail. So actually, let me go bring up my flag information so I make sure that I'm checking everything I need to check for. So let's just go have a quick look at this. What do I need to have in terms of my flag for the registry scan? Let me just quickly check that. Okay, so let's fix this. So let's change that to 1. So I'm going to remove soft fail over here. I'm just going to show you the first one, and then we can go because of time. So I'm going to set that to true. So fail if essentially what that means is fail if the security check fail. It's all these flags that I'm using. So I'm going to save that, and I'm going to add my commit message. So testing security, testing automated security pipeline checks. And if I go ahead and start that, so and that's committed. And what I'm going to do is I'm just going to go ahead and push that. So if I head over to my Azure environment, if I go to my project, if I go to my Prisma Cloud Shift Left project, and if I go under pipelines, it should have triggered the pipeline, which is just started now because of the change that I just made and the commits I just pushed. So, and if I go over there and if I go pick that particular check, you can see that it's going through these different stages, which have defined the different checks within the different stages. So let's go over to have a look. So it's already started the first phase, which is the scanning the code in the repo. It's checking the dependencies before it even gets to start building that. So, and that's going to help me to identify any issues that it finds. And the service that's powering this, if I go over to my environment over here, so while it's running that, let me show you the service that's powering this. So I've got Prisma Cloud. Sorry, Prisma admin is what I need to use. Okay, so what I've done here is this is sort of like a centralized policy where I'm controlling everything. I've gone to the defend section, and
if I go to, so I'm checking for vulnerability issues, compliance issues, malware issues. So I can show you that. So for example, I've enabled malware checks, especially for issues like malware checks that's growing these days. So I've enabled that in terms of my environment over here, and I'm checking for that in CI. I've also defined an organization baseline policy for vulnerability check. So this is for CI too. So that's the vulnerability policy that I'm going to be using to assess things in my CI. So again, I'm controlling things centrally. Any medium level vulnerability is going to fail. If their vendor fixes not available, I'll skip those because there are no fixes available and all the other stuff. So that's what I've defined there. So I've defined that for my code repository, for my CI, for my code repository, I've defined this. And I actually just got an email now that failed. So let's go have a look at that. So it's going to fail in a minute because I just got the email. So yeah, and that is essentially, let's see. And that's essentially what it's calling out to me here. So it's calling out the different issues that it found. So you can see it also checking for licensing issues in terms of compliance issues and what different licensing. So it's like, it failed. So it's going to fail in a minute because I got the email. But for some reason, Azure Pipeline is taking a while to reflect what I just got in the email. Anyways, well, you can see it found licensing violation issues. It found dependency issues also with that. So not sure why is Azure Pipeline not. It's already okay. Yeah, it's just stuck. I'm not sure why it got stuck there. But anyways, I got the email already that it failed. You can see that failed. So and all that stuff. So, but essentially could not proceed to the next one. So what I'm going to do, ladies and gentlemen, in the interest of time, is I'm just going to go to allow all these different checks to proceed, and then I'll show you some of the different stuff that we have with them. So let's go to the dockerfilescan. Where's my dockerfilescan flag? What flag do I need to have that temporarily skip? So I'm just going to set that to soft fail. I'm going to set my Terraform to soft fail. I'm going to set that to soft fail. I'm going to set this to false. And I'm going to set this to false also. Okay, no, it's okay. That's fine. That can be true because that's controlled somewhere else. Okay, so I'll just go ahead and save this, and I'll go ahead and run that one more time. So test security checks. And that's going to commit, and I'm going to push that, and then that's going to trigger another run. But this time around, what it's going to do is that it's going to skip. It's going to ignore the checks that fail so that I can show you. So this is only just so I can show you the different steps that I've put into the different stages. Excuse me. So it's going to run through all of them. It's not going to fail on the check, but I'll be able to review what happened. So while that is going on, so what I'll just do over here is I'll go ahead and in the interest of time, because I can't really go over the others in terms of talk about some of the different assessment and check that I've put in place and everything. But again, reach out to me on Twitter. So my Twitter username is @Asegunlolu, ASEGUNLOLU. So reach out to me on Twitter, search for my name on LinkedIn, and we can carry on talking about this. But I won't be able to go through like everything. Apologies because of time. So I'll just wait for that to complete. While that is running in the background, I'll take any questions that we have. So anybody has any questions, please feel free to unmute your mic or put something in the chat window.
Sorry, I had a question. How do you take care of the runtime security for the container?
Good question. Very, very good question. So I can show you, we can try to see if I can show you an example of that.
Yeah.
Let me go connect to my AKS cluster. Let's go to AKS. Let's go to the AKS cluster that I deployed earlier. So that's my AKS, and if I go to on the So first of all, I need to essentially deploy something called a Defender. If I'm using something like AKS, for example, I deploy something called a Defender, which is a daemon set, right? So it's a daemon set that's running on that. If it's for a serverless runtime environment like Azure Azure Container Instance, or Azure App Service, or Azure Functions, or even Azure Badge, I can embed something called an app embedded Defender in those serverless environments. Yeah. So
we need to enable the Azure Defender on AKS, which would actually run a daemon set on the container, on the pods.
So this is not the Azure Defender that I'm referring to. So I'm referring to the Prisma Cloud Defender in this case.
Prisma Cloud Defender.
Yeah, because that's what I'm using for the demo. So there are things that to look at. So when we're talking about in terms of the types of check that you're checking at runtime, the main things I'm talking about here is this. So let's go very quickly to, if I go under Defend in Prisma Cloud, if I go under Defend and runtime, if I go under my runtime policy, so let's go to add a policy for containers that's running at runtime. If I go to add this, you see that this is essentially where we're defining processes that are allowed or not allowed, right? So defining processes that are allowed or not allowed. And this is a very interesting one because it's not just being able to detect and identify stuff. It's actually being able to say, if something violates this, it will be denied from running. So for example, if as an attacker, I'm able to land on a container at runtime, exploit an unknown vulnerability or a misconfiguration, and if I run a particular command, it's actually going to show not successful. It's going to show not run. So block, if I go to apply block, what that's actually going to do is going to say, this container is misbehaving in production. I'm actually going to eject it from the cluster. And I'm going to pull a new clean image from the registry and run to replace it. So this is not just about the alerting, this is about being able to enforce the behavior that you want. And again, it's looking at it from this perspective of what process is it trying to run, right? Is it trying to write files on the file system where the files are malware, for example? Is it trying to write file to sensitive location like /root on the system, right? What is it trying to do? So you're looking at it from the perspective of the malware, of the process that it's running, of the networking. What network communication is it making? Are those to suspicious IP addresses? What DNS is it communicating with? And this works very well for containers because for containers, they typically do one thing, right? Microservices, right? That's what allows us to be able to scale massively because of microservices. So in other words, as an app developer, I can go, this is the behavior of my container that I'm building. This is the behavior of my microservice. If it deviates from that behavior, then that's something is wrong. Plus, what Prisma Cloud has that I really like is that it has this thing called, if I go to monitor runtime, it has this thing called container models. And what Prisma Cloud is actually doing here is that it's going to take every single container that's running in your organization at runtime. It's going to build a model for every single one of them. So for example, it says, from what I've learned from, let's pick maybe another one, like maybe this one. In some cases, some of them are excluded. It's going to say, from what I've learned from the static configuration in this particular image, these are the processes that I should run. Anything that deviates from that, I'm either going to alert, prevent, or block, or eject it. So behavioral is where it's actually going to let it run at runtime and learn the behavior automatically without a human getting involved. Anything that deviates from that, then it blocks it, right? And same thing with networking, same thing from file system. So you can learn those dynamically and statically, and then you can use that to create a rule by yourself, or by default, you can have a baseline rule that says anything that deviates from the behavior that's learned or behavior that's defined in policy as code, alert on it, prevent it, or eject it and pull a new image. Hopefully that makes sense to you.
Yeah. Thank you very much for explaining that.
No problem.
Natively within Azure, because obviously this is we purely used Palo Alto's Prisma Cloud here. Obviously, natively within Azure Security Center, there's I don't know what it's using now. But there's container scanning based in there every time an image is pushed
into the registry.
It's scanned, and I've seen, yeah, that's right. And
so,
I think under preview, there's now integrations into GitHub with Azure Actions for container scans. Do you know anything around if that's being extended to Azure DevOps?
Yeah.
Whether they're going to be doing any sort of runtime scans as well there?
So I'm not sure. I've not heard anything. So I've read that document in terms of what the integration that exists in GitHub. My own approach to that is sort of like if I'm looking at the holistic approach, right? I'm looking at the holistic approach, which is this sufficient if I say before I deploy an image? Is that sufficient to say all I'm doing is a security and compliance check before I deploy the image? What about malware scanning, right? With all the new malwares that are detected all the time. If I'm doing a check and I'm saying, oh, I'm going to, after I push an image into the registry, I'm going to scan it. How about scanning it before I push it into the registry? Because now I have a dirty registry. I have a registry that's full of all kinds of.
Yeah, I understand that. I just thought, are we basically just saying that Microsoft do not currently have that capability? So
there are gaps.
You've got to go to someone like Palo Alto, because it's a scan image is based by it's Qualys, isn't it? That's doing the engine.
Yeah, it's Qualys that's using at the backend. So there are definitely gaps. So even like runtime, so Azure Kubernetes Service has a runtime capability called, which is the Azure Defender for AKS, right? But what that's doing is it's just using OPA gatekeeper capabilities of Kubernetes, right? But it's not really looking at things like the processes and the runtime, and the processes and the file system and other behaviors that you could be looking at. So, which is the reason why, Microsoft, has amazing container services, and then working together with, let's say, like a partner that's sort of like bringing that security capability, especially when it comes to container security, because don't get me wrong, Microsoft do amazing things when it comes to security in terms of other tooling that exists on Azure. But when it comes to container security, there's still a lot of gaps in my own honest opinion.
Cool, thank you.
No problems.
Sorry, just quickly, Prisma Cloud, which has been brought by Paolo, is that the de facto number one to your mind? We're potentially looking at that and Qualys. I think Qualys is lacking from what I can tell.
Yeah, so I'm not going to go ahead and say which one is this one, but however, when it comes to, so for example, Microsoft used to have this thing. So if I go to AKS environment, and actually, you know what? Let me go to the AKS security best practices page by Microsoft. So one of the things that Microsoft has is they actually call out certain things. So if I go to, let me quickly bring this up in my other environment. So I won't give my own commentary about that because my commentary could be biased and all that stuff. However, what you see over here is that Microsoft does call out when it comes to the security best practices, which I mentioned that the best way to do this is to codify things, is Microsoft does call out some of the gaps that they have, and they're talking about including your flow capabilities like Twistlock. So Twistlock is what Palo Alto is about. So that was the company that was acquired by Palo Alto, which is Prisma Cloud. And they also mentioned Aqua Security. So those are the names that you hear a lot when you talk about container security these days, in terms of people that are doing sort of like the top of the range stuff. So, however, I'm not going to put down what Qualys are doing because security,
Yeah, no worries.
Anyone innovating security, no problems. Yeah.
Cool, thank you.
No problems. Let me have a look at my pipeline. Let me see how it's going. Yeah, so everything looks okay. So it seems as if I've not disabled that. I'll just quickly end with this one. So you can see the scan that I'm doing here. So I'm doing a scan of the repo. It's identified issues, licensing issues, which is compliance issues, vulnerability issues. If things are caught at that point, it failed. Before I go ahead and use my Docker file to build my Docker image, I check the configuration. And I'm identifying issues here like it's using a user that's root. It's exposing ports like ports 22. If you do that on a service like, and this container image ends up on a service like Azure App Service, that's a big loophole. Go find out, go type in app service, checkpoint, vulnerability, and you see some quick information about that and stuff. So, checking all those before you actually get to start building. So now when you're doing the building, doing checks like after you finish building the image, why do I need to have a dirty registry? Before you push the image into the registry, let's scan it first of all. Let's check the OS packages. Let's check the binaries. If it's all good, then that's fine. If not, that's not going to proceed. That's not going to push it into the registry. If it passes through that check and it goes through, and we're going to be dynamically building an environment, let's say Azure App Service or functions or ACI or stuff, I can embed the runtime defender into that. But I can also check in terms of how am I configuring like my AKS at the disk encrypted and all those stuff. So I'm checking all of those. And if that's not successful, so those are the kind of things in the best practices. If that's not successful, stop. And whether that's using Ham template or Terraform. Now, before I go ahead and deploy an application to production, I'm doing another updated assessment of that, pull it from the registry, do another quick check before you actually go deploy that. Then we get to the deployment stage where we apply the runtime policies as code and other things. So those are the kind of checks that we have. Okay.
So I can just ask one more very quick question. It's product specific to Prisma again. So I've sort of looked at it briefly. Yeah. So Prisma, you can have policies, can't you? So then these scans are going to check against your policies. Can you integrate that directly with Azure policies? So you're not doubling up on policies everywhere?
No, not at the moment. No.
Okay.
So
Sorry, and one more thing. I think I've read somewhere as well that with Prisma, you can actually, via an extension, embed that into your IDE, such as VS Code as well. So you're actually checking a lot of this stuff before you even. Yeah, that's right. Cool.
Yeah, that's correct. Yeah, so things like your Docker file, and again, that's shifting it further left to the developer tool set. So to where before they even actually pre-commit in the repo, they actually detect this stuff and they address them pre-commit. So yeah, that's true. Okay, so thanks very much, ladies and gentlemen. I really, really appreciate you taking the time to join this session. I hope that you've learned one or two things from that. I'm always happy for a chat again. Hit me up on Twitter, on LinkedIn, and I'll be happy to carry on. But for now, I'll hand over back to you, Rebecca. Thanks very much for that.
Thank you so much, David. This was fantastic. Thank you all also. I know we ran over time just a little bit there, so if you had to pop off, please do so. If you want to revisit any of this content, again, this session was recorded, so it will be available in just a few days on our YouTube channel. I dropped your link, David, to your YouTube into the chat as well, so they have access to that. Hopefully everyone checked in and they were able to get some of the session resources, which I included your YouTube channel in there as well.
Thank you.
Of course, if you're new to Microsoft Reactor, please note that we have a number of physical locations that one of these days in the near future we'll be getting back to. So if you're interested in coming in for workshops in person, we have a few around the world. We also are running a constant on virtual sessions. So depending on where you're located, or on your schedule, if you happen to work an overnight or something like that, we generally have sessions around the clock, Monday to Friday. We're always updating, so definitely check out all of the new content that we keep posting. If you're not a part of our community, do consider being so. Visit microsoftreactor.com for updated calendar. We also are on Meetup, so you can search for the Microsoft Reactor on Meetup and find a location close to you. You can find us on Twitter. We usually highlight sessions there. And also, if you are interested in a monthly email just with a quick blurb of any highlighted sessions that we already had upcoming for the following month, aka.ms/reactor email sign up for that as well. Now at this time, I think we've covered everything. David, once again, thank you so much. This was a great session. Have a good day, everyone. Take care.
Thanks. Bye.